I think we're going to start seeing systems that write their own code in real time based on the objectives that they need to do. So if they don't find the tool to execute the job, they're just going to write it themselves.
Welcome to the / podcast, where we lean into the future of IT by inviting fellow thought leaders, innovators, and problem solvers to slash through its complexity. I am your host, James Carman, and today we're talking to Yaron Schneider. Welcome to the / Yaron.
Thank you so much for having me.
Yeah, absolutely. Yaron is the CTO and co-founder of Diagrid, where he's driving innovation in cloud-native and distributed systems. He's best known as the original creator of KEDA, which is the Kubernetes event-driven auto-scaling, and Dapr, which is distributed application runtime, two open-source projects that have become foundational tools for building scalable event-driven applications. Passionate about simplifying complex architectures, Yaron is helping developers around the world unlock the next generation of cloud computing. I got to hear about, I think I know KEDA. I've heard about that, but Dapr I'm not familiar with. Tell me a little bit about, I want to hear about Dapr.
Dapr, yeah. So Dapr, as you said, stands for Distributed Application Runtime, and that does really tell you what it is. Mm-hmm. So I'm just going to run through what it does. In 2018, Kubernetes really, started gaining traction across both enterprises and startups. And the CNCF ecosystem, if you look at it back then and also today, it's filled with DevOps related tools, right? It's all about networking and storage and compute and monitoring. And that's all very low level stuff that really talks to DevOps engineers. But when you go into pretty much any company, you find out that the average ratio between an application developer team and DevOps team is 10 to 1 in the favor of app developers. And so you've got all of these application developers who now need to find themselves writing distributed microservices in this new Kubernetes world. And they don't have the tools to do that because everything's focused on the DevOps folks. And so Dapr really started as a tool to help developers focus on business logic and not need to do any sort of complex infrastructure interaction in their code. And so Dapr is really a set of APIs that allows developers to do things like service discovery, pub sub, state management, workflow orchestration, configuration management, secrets fetching, really, really easy, and also abstract over different cloud technologies. So, for example, if you're a company and you've chosen Apache Kafka for your production workloads, and you've invested 6 months and $3 million in time and materials to basically build that out through your architecture, but 6 months down the line, you find out that it's no longer feasible for you because you missed something really critical in the evaluation stage, and now you need to rip it all out, and that's going to take you an additional 6 months, an additional $3 million. Well, with Dapr, it's literally going to take you 5 minutes. And this is something we've actually seen work in the real world. It gives you this abstraction over many, many core technologies, not just in a single cloud provider, but also between cloud providers. So for multi-cloud shops, this is even greater because they don't have to maintain and write multiple code bases for multi-cloud deployments. They only have one entry point into the cloud, that is Dapr. And because of our great community, we've got more than 120 different components that you can abstract over.
Oh, that's awesome. Yeah. And I love, as a software architect, you always hear that, we want to provide this abstraction over this because what if we need to switch it out? We're never going to need to switch that out. Yeah, until the time comes when you do, right? Yeah. I love it. Okay. I haven't had a chance to play with that yet, but I'm definitely going to look into Dapr for sure. Sounds like you've done your fair share of building distributed systems. How long have you been in that area, doing work in that area?
Yeah, I would say for about 15 years now. Mm-hmm. And really started with working for startups and creating the infrastructure there. So I was a CTO at a startup called Yaron Schneider. It was a 20-person startup. Then we got acquired by a larger startup called After Download, and then merged with another startup called Supersonic. So I went through the startup phase before I started working for the Beast of Redmond, also known as Microsoft.
I've never heard that moniker. I love it.
Yeah. Maybe it's only used in Washington State. I don't know. But so I started working there as a solution architect, working with some of Microsoft's largest customers with a focus on distributed systems. Then got to work for Mark Russinovich, the CTO of Azure, where our team was basically tasked with finding what gaps Microsoft can fill in the cloud native space and then gain an edge over its competitors, which are Google Cloud and AWS. And that was really fun because there I got to work with lots of open source projects and also got to create ones.
That's fantastic. Yeah, I love the CNCF and the community, and I've been a longtime member of the Apache Software Foundation, so I'm big into open source, and I think they're doing a lot of cool stuff. I never really thought about it that a lot of the stuff is very DevOpsy, and that not really for us application developers, is more for kind of those systems people and DevOps folks. So, okay, so you've been doing distributed work. Now, did you have the privilege of being around for like the enterprise service bus and the SOAP and all that stuff? Did you deal with that stuff?
I did, but it was its dying days, really, when I started. So I got to basically see it sink, or phase out and give way to something new, something we call microservices today. So ESB was very common in SOA architectures, service-oriented architectures, which is kind of like it involved. It's kind of like what we call microservices architectures today, right? And like the whole concept of a centralized something, like the ESB made its way just into a service bus. We don't call it enterprise anymore. That serves a very specific focus. And so I do believe everything we have here today is really standing on the shoulders of giants, even if we don't call it the same way anymore.
Yeah, I think that whole idea, we went through that phase where enterprise service bus was that was the brains. All of the logic was kind of built into the bus. It was a kind of a smart bus. And now we're more along the lines of having fast pipes and all the business logic outside of it. So we're doing more event-y type stuff. So I like this world better for sure. What's your take on the, kind of the microservices? How was your experience on that little roller coaster we went through where we, everything had to be microservices? But how was your experience through all of that?
I believe microservices are the most gamified thing in the world of tech, and I'll tell you why. I don't know if you play games. I'm kind of like a gamer, I do, but many people, they play games and they do it for the achievements because you want to unlock something. And any company that I see trying to tackle microservices, it's like this holy grail of challenges that you must unlock. Like I did microservices correctly. And this is really like, I continue seeing that, and people just want to be able to, tame this beast and just do it right. And there is like a million ways of doing it right. And there's like 5 million ways of doing it wrong. So it's a fascinating world to this day, where companies and developers are just trying to conquer distributed systems. And it's fascinating seeing the different solutions that always come up to help them do that. And there's like, oh, we just need this one more tool and then we'll get microservices right. That makes me laugh.
Okay. I think the audience needs to understand and appreciate what I'm going through right now. So we didn't prep for that answer. I am so happy right now that you provided that answer, that like microservices is like badge hunting for gamers. Like I want to get that achievement, and that is so funny. I am so glad I asked that question. That is a fantastic answer. I love that analogy, and it is so true. It's like, oh, we got to make sure we're using this technology, and then this, and then this, and oh, we're not doing circuit breakers. We want to get that little merit badge for circuit breakers. Yeah.
Yep. For
sure.
Oh
my goodness.
And you see people like, trying to break down the monolith. That's the greatest evil that they have in their careers. Like, look, I'm all about microservices. Like my business is centered around helping developers, create microservices easily. But sometimes, for example, if you're running cloud infrastructure, you'll want to do a monolith, right? Like if you go and take a look at the architectures that AWS and Google Cloud and Azure have for their core services, usually it's not microservices based, it's all monolith based. So I just want to say to people, there is room for both architectures. It really depends on what you're trying to do. Microservices is a great tool to have in your toolbox, but you need to make sure that you actually want to go down that rabbit hole, and you shouldn't unless you absolutely have to.
Yeah, I think the early on days when they coined the phrase microservices, I think that was just such a disservice to the industry, because you would see things like, okay, microservice has to have as minimum lines of code as possible. If you have any more than 10 lines of code, it's not a microservice, like that sort of stuff. Yeah. So you ended up seeing like this table as a service stuff. People would have database table as a service. So you could basically, all you had was CRUD. There was no business logic anywhere. It had to, all the callers had to do all the business logic. It was a nightmare. It was crazy. I think it's really all about like kind of right sizing the services instead of trying to make them as small as possible. Just make them the right size. Because some of the things people call monoliths, I don't find to be particularly large systems. I don't feel like they're that way either. So
I definitely agree. Size is relative. And, sometimes you'll see companies with like 10,000 Lambda functions, and you'll ask them, well, why? And they'll go like, oh, because we wanted to make them as small as possible. So we just split every piece of logic into its own function. And now we're paying a lot of money for this. And our latency is super high because we're just introducing call graphs where a function calls a function, and before you know it, you've created more spaghetti than what you've had before.
Yeah, I can only imagine an environment with that many like lambdas. That stuff just always is mind-boggling that folks had that sort of mentality. Yeah. But we seem to have kind of settled, I think some of you'll hear like, I don't know if you're into like the Spring community, but like Spring even has like the modulith, Spring modulith. You're hearing that thrown around now, modular monolith. So we're settling back into more reasonable, but I think a lot of, I think the hard part of building distributed systems is, it's, you got to think in events, right? That's kind of the core part of these distributed systems. How's your experience been with kind of making that transition or working with folks to make that transition to think more in event driven and sharing events among systems?
Yeah, there's definitely some challenge there, when developers really know things like HTTP, right? That's like the most basic thing that when you come out of school and you have an HTTP client that makes a call to an HTTP server, really easy to grasp. You understand everything that's going on. It's kind of observable. JSON is pretty much human readable, so everything is fun. But then, explaining to developers what are the benefits and merits of an event-driven architecture is more difficult because oftentimes those message brokers will have their own schemas and their own protocols, and things will be encrypted, and you don't necessarily see what's going on behind the scenes when the message broker tries to deliver messages to the consumers, and it just becomes more of a black box. And developers are rightly so afraid of black boxes because we want to be able to, see and visualize everything that we do. But it's really about giving reliability at the most fundamental level of transports for application. This is really where event-driven systems excel. First of all, they can make your system a whole lot more scalable because you're not blocked on CPU and I/O, just waiting for something to come back. You just send something off and then you're free to handle the next request. So many systems today couldn't have handled the scale that they use with the amount of resources they do unless they offloaded those events to other services, microservices, nano services, whatever it is you want to call them, just other services that are consumers of those messages asynchronously. They're seated somewhere just waiting for something to hit them, process the work, and then reply back that the work is done. So there is a lot to be said about the resource consumption side of these things too, the scalability of systems. And in many cases, I also think it's making programming easier. Because to me, writing a function handler that does a job and just waits on something is easier to grasp than needing to return the response, serialize it back instead of just processing the response and sending it back to the message broker, which in many cases have really, really great SDKs to do that. So to me, it's also a personal programming model preference thing, but I can understand why many people just prefer the good old HTTP synchronous route.
Yeah, and we made it, through the years, because as you said, HTTP's kind of been the king, right? And we've made it really easy. It just looks like a function call, and that's all it is. Behind the scenes, there's a whole bunch going on there, but it for the most part works great until it doesn't, right? Like when you're 7 calls deep in blocking HTTP chain, and that 7th one decides, oh, I want to take 10 seconds to answer your question. Well, now you've got everybody holding on to database connections and all of these things going on 7 layers deep, and everything just comes to a screeching halt.
Yeah.
That's when when something goes wrong, it goes really wrong when you're doing all those synchronous calls.
Yeah, and let's not start talking about the pleasure in quotes of configuring HTTP servers and finding out why their defaults are so low and how you can change them to basically increase the parallel throughput of calls coming in or the limit size of messages that are coming in, and suddenly you go with the HTTP server's defaults, but a week after you put your system into production, you find out that you're getting bigger payloads than what you anticipated. Your system breaks down. Now you're on the hook for it. You need to look into the source code of the HTTP server sometimes. Yeah, that's just not nice. As message brokers, they usually come with much higher throughput limits and more sane defaults, I would call it. So your chances of just taking something as the default configuration, putting it out there, and achieving what it is you want to do, these chances are much higher than just doing it with an HTTP server for any high-scale workload, I would say.
Yeah, I think it's natural, kind of as you were talking about earlier. It is just have a function that handles something, and then like just how we communicate with other folks. Like if I ask you, hey, can you look something up for me? I don't sit there and wait on you, watching you to do that. I say, you'll get back with me later. That's kind of how we communicate as human beings. You would think it would be natural to kind of have that asynchronous nature just kind of built into our software too. But, it's weird. We don't. So distributed systems now, I know we've done, event-driven architectures and all that for many, many years, but now everything is agents. So we don't, that problem's now solved. So, the agents just solves everything, right? We just call it agents, and it's just going to be done for us. We don't have to think about this stuff anymore. It's all the agents will do it for us, right?
Yeah, that's
pretty much as easy, right?
That's the Kool-Aid. Yes.
Yeah, I have a feeling you're not drinking the Kool-Aid, like I'm not either. This whole agent thing, it's interesting. I don't know. Some of the stuff, and I don't know what your experience has been, but I see this term agent being thrown around. And a lot of the stuff I see, I mean, the worst violator of kind of the misuse of agent is like, it's just a function call. Some people will say, oh, I've got an agent that can tell you what the weather is in Seattle right now. Well, that's not really an agent. That's kind of a web service, really, if anything. Yeah. So that's kind of the worst. But then, there's this like middle ground of like, what a lot of people kind of assume is an agent really kind of smells and feels like an event-driven system like we used to have back in the day. Like, oh, an email comes in and it does something based on that email. Well, an email is kind of, it's an event, right? I mean, it's a type of an event. What's been your experience around that?
Yeah. I have a different take on agents, I think, that some people do share. And to me, it's all about autonomy and automation. Agents are, in my view, the systems that are best positioned today to really take automation to where we always wanted it to be. And they're really only useful if you give them autonomy. So yeah, I mean, if you want to automate the weather, then yeah, I guess you could say you have a weather agent. That's great, but usually you don't want to automate like weather responses, right? So it doesn't fall into that. But let's take a real world example, one that I've literally came into yesterday. I'm talking to a logistics company, warehousing company. They have nothing to do with tech. They have like maybe 5 or 6 developers, doing their back end systems. But then they suddenly realize, oh, we've got this manual process where we have a bunch of people just watching a dashboard for orders that come in, and then you need to go and do SQL queries, and they don't even understand SQL. And then they have this formula they basically need to calculate and then make a decision based on that. What if we could actually automate all of that? And that's really where agents shine. They're able to take like these very arduous, difficult tasks that don't really involve, I would say, much introspection into what's going on, just being able to automate all of them. So agents are really the epitome example of processes that you don't want to do, and you just want to hand them over to something that has enough wits and reasoning abilities to figure out what needs to be done, and then provide the best answer. But if it can't, it'll involve a human or another agent in the loop to basically make sure that it drives the best outcome possible. And this is what an agent to me, event-driven or not event-driven, that's a way to implement an agent. But yeah, it's not necessarily, what an agent is.
Yeah, I think it's part of being an agent, that whole aspect of being able to perceive the world around it. And one way we do that is with, notifications or events or whatever. But yeah, I think there's a bigger picture. So is the distinction, this has been something I've struggled with. Like, how do you kind of put a nice little box around what is and is not an agent and what should be? Is it about like whether I'm deterministically telling it what to do in code? I'm spelling out the recipe. This is exactly what you do. Like if I'm doing that, that's not really an agent. That's not really autonomous. It's just an order taker. Whereas these autonomous agents, they have the ability to think and react, and they may do unpredictable things sometimes, which is good and bad. Sometimes they get creative and do things and you're like, wow, I wish I'd have told it to do that. That was really cool. And sometimes it goes crazy. Is that the distinction, that it's not like discrete code telling it what to do? It's thinking its way through.
Exactly. Software up until now has been totally deterministic. You've got every app is a workflow. You've got a bunch of codes that you need to execute sequentially in parallel. It doesn't matter. Everything is technically compiled. The program knows what it needs to do. Agents are kind of like creating real-time workflows and making autonomous decisions based on what needs to be done and which tool they're going to call or what system they're going to interact with or what logic they're going to process based on the prompt. So yeah, it's determinism versus non-determinism. And throughout these last 40 years of software, we've been really focused on deterministic processes. And look at all the challenges we've had with deterministic processes, right? And now something non-deterministic comes along where you're basically handing off your most precious logic and access to your digital infrastructure to something that is an LLM, which is a very big black box. And you need to figure out a way to make it work reliably. And that is very, very difficult to do.
It's just kind of as you're describing that. I love the way you, I'm trying to remember how you phrased it exactly, but like it's like a real-time workflow. It's determining the workflow at runtime and understanding and saying, okay, I'm going to go do this and this and this. And it may not be the same path every time. And like what popped in my head is, do agentic and these autonomous workflows like you're describing, does that, may not completely, but like, does that obviate the need for a dead letter queue, right? Like, shouldn't an agent be able to, oh, wow, that service is down. Let me try a different path. Let me try something else. Instead of just giving up and saying, just throw it in a dead letter queue, I'll work my way around. Is that maybe, would that be one byproduct of this kind of agentic world we're getting into?
It would. And I also think this is where we need to create the infrastructure layer for agents, because agents will need something like dead letter queues. If they decide, look, I'm going to try to talk to this system, but I can't, so I'm just going to put it here for a while and then go ahead and retry it sometime later. So agents do need access to things like pub subs and service discovery and HTTP calls for them to be able to discover the world around them and interact with it. But yeah, I still think all of the technologies that we get from the microservices world are applicable to agents, because agents are really microservices with smarts. It's basically a microservice with an LLM, and the LLM determines how the workflow is going to get executed. But you still need communication, still need telemetry, still need security, still need identity at the core concept, because now you're giving agents access to a whole bunch of data. And in many cases, you just want to give them access to a slice of the data, not the whole thing.
Right.
So you still need RBAC permissions. All of those technologies we used previously, dead letter queues, are still applicable to AI agents, in my view.
Yeah, I guess the way I was thinking about it would be, in the past, it would be when we're telling, writing explicit code that says, do this step, then do this step, then do this step. If something goes wrong in that explicit, we told it exactly what to do. That's when we'd be like, oh, something's wrong. Let's just throw it to a dead letter queue. Whereas with an agent, it might be able to analyze the current situation and say, I've got another plan. Let me try a different way to get to my goal that I want to get to. So maybe we'll have less populated dead letter queues. I think it'll still happen, yes, but it's just an interesting thought. One thing that is a little different with agents is that, and you kind of hit on it, they are stateful in nature, and it's almost like what we used to call a continuation, right? They have a plan. And, or first they have a goal and says, I want to achieve this goal. And then it comes up with a plan. Here's what I think I'm going to use the steps to get this done. And then it needs to know, okay, I'm going to employ some other agents or whatever. Then there may be requests that are out there pending that might come back later at a later date. When it comes back, I need to know what to do. I need to know where I was in that plan. So it's kind of like parking these things. That's somewhat of a unique aspect of this. We used to do a little bit of that with event-driven systems, but I think this is going to be another piece of infrastructure, is that whole continuation and remembering where I was. What have you seen in that area?
I think that's actually the most important part of agents today, that we need to get right for sure. It's what I would call an agent's durable execution. You want to make sure that if an agent now needs to do 500 things on your behalf and it fails at thing 499, that it's not going to need to replay the whole thing from the beginning. Because guess what? An agent is useless without LLM calls. And guess what? LLM calls are extremely expensive. So if you're going to, fail at step 499 because AWS went down or because somebody did a scale out to your system and the process crashed, you really don't want to pay for all of those calls beforehand or make your CPU and memory bottleneck grow. Having agents not needing or not losing state and remembering their context, I think, is crucial to taking them into production. And many people don't realize that today, because it's essentially in the toy status for many people. It's just a POC that they're running on their machine or several Kubernetes clusters, not in production really yet. But when you give these agents more access into your system, that's when they really give you a great ROI, because the more they automate, the more you gain out of them. Mm-hmm. But for more of them to automate, the more autonomy you need to give them, and the more autonomy you give them, the more can go wrong. So you really want to make sure that you have this stateful workflow concept at the very heart of every agentic operation that you do.
Yeah, I think as you were describing that, going through 400 steps or 500 steps and 490 kind of brings back that saga pattern, right? That's kind of how we would do it in the microservices world, because we don't have distributed transactions. But that was very much kind of like a linear, like I'm literally going to do 400, 500 things. And if the 499th fails, well, now I got to go back to all the previous 498 and mitigate those or compensating transactions to undo. Like I might send an email to a customer to say, oh, I know I just told you we're shipping your order, but turns out we don't have those things. And so we're not going to be able to send it. So, and then refund their credit card, those kind of things. With agents, it's not linear. It may be branching in nature or even cyclical, right? Oh, I tried this. It didn't give me a good answer. Let me try a little better way to describe what I'm looking for. And so, yeah, that's like I don't know, maybe it can't be a DAG because it would be cyclic. It wouldn't be directed acyclic. So it's a different structure of a saga, but I think it's better at recovering and working around those road bumps, those speed bumps that happen or those bumps in the road as it encounters them. So it's interesting to think through some of these patterns we've always had in distributed systems. What about, some of these things like the enabling system. So there's a couple different, technologies that have come up in the past year or so that people kind of latched onto. So specifically, agent to agent or like MCP, do those, is that just an extension of what we've always been doing, or is that a real novel thing? Is that completely new, or is it just kind of a retreading of an old tire that we've always had?
The latter, for sure. Okay. A2A, if you think about it, is just JSON over HTTP, right? Mm-hmm. The thing that's special about it is the content of what that JSON means to agents. And that is, telling one agent, look, you've got message from that agent and it wants you to do this thing. So you can reply back and say, oh, I'm busy, go try another one, or mm-hmm. this thing is now in progress. And also tell the other agents who you are, what you can do in the world, how they should authenticate to you. So it's much more of a discovery mechanism that is built on top of primitives that we already knew, like HTTP and JSON, or service-side events, which are just transport mechanisms. Mm-hmm. It's not novel. It's just like MCP, right? MCP is a web server returning a JSON, an array of JSONs, telling you which tools you have, and this is literally it.
Yeah, it's funny. All of these things, as we get through kind of the hype cycle. And, I've talked about this with other folks. It's like we had the hype cycle, everything was crazy and everybody's learning about this, LLMs and agents and all this stuff. But then as you kind of like take a step back, what are we doing here? What's the real problem we're trying to solve? Oh, okay. Well, we really have an answer for that. So you're really just kind of adapting an old technology here. Once we start getting back to like the first principle thinking, what's the business problem we're trying to solve, or what's the problem here and then we're trying to address it, everything settles down a little bit when you get back to that kind of first principle thinking, I think.
Yep.
All right. Well, this has been cool. I mean, I love talking distributed systems. I've been doing that for a long time. It's been kind of my world. I was in like the ActiveMQ community and Apache Camel. So I've been doing a lot of these kind of integration workflows, event driven. Man, we could sit and chat for hours, but we have to move on to our next section of our show, which we call Ship It or Skip It.
Ship or skip, everybody we gotta tell us if you ship or skip.
All right. This was something. So I had, of course I have to use ChatGPT to help me with everything I do now because I don't have a brain anymore. So ChatGPT recommended, I didn't know this was a thing. So I thought this would be interesting because you're kind of in the Kubernetes community. It said, what about the no YAML for Kubernetes? Like, is that something? Are people getting rid of YAML? I thought the Kubernetes folks loved YAML.
Yeah. Ship it for application developers. Because application developers, and this is the persona I'm going to represent here today, should not have to do anything with YAMLs unless it has to do with their actual application logic. YAML is great for configuring Kubernetes, but if you're an application developer, you shouldn't need to think about it in terms of how do you discover services or how do you authenticate to anything. You need to be able to do that through code because code is where you live in the IDE. And so you don't want to introduce external configuration unless you absolutely need it. That's the world of platform engineering and DevOps.
Gotcha. Well, if that's the gist of it, I'm gonna ship it as well. I hate YAML. I had a side client that I was working for at one point that was a Ruby on Rails shop, and all of their HTML pages were YAML templates. And there was a place where the indentation was messed up in one certain spot. It took me days to find that problem. So I hate YAML. But yeah, I like the idea of using code, even for like the, Terraform and that, infrastructure as code. I would rather kind of have function calls and that sort of thing and not this, nested YAML structure. So, all right. I'm with you on that one. I'm going to ship it. What about everybody for a while in, distributed thing? And you kind of hinted at this earlier, but like everybody thought that like serverless was kind of that was the holy grail. That's where we need to get to is everything is just serverless. That's the best way to do. And that's a one size fits all. You should just do serverless. Where are you at on that one?
Skip it.
Okay.
I think the runaway costs and overall complexity of doing serverless at scale is just not worth not managing your own infrastructure. This is something I've seen personally, both at the engineering practice of my company and our customers as well, and also at Microsoft. If you look at AWS, for example, like they released this blog post, I think it was 2 years ago, where they basically said how Amazon Video basically went off and just killed their Lambda architecture. Like they got away from serverless altogether, and they were able to save a lot of costs and a lot of operational overhead just by doing that. And so you're telling yourself, if the company that kind of like invented this really to some extent is moving away from it, then what are we really doing here? And yeah, I think, today with ChatGPT and LLMs, like knowledge is so pervasive everywhere that even small shops and small teams can get started with something like Kubernetes. Or if not, you've got great partners, in the IT ecosystem that can help you. But then being able to control your own destiny, I think, is extremely important to any software practitioner.
Are there any workloads where you would see that, okay, serverless does make sense here? What is the distinction for you where you would say, yeah, we could probably get by with serverless for that?
Very small websites running on something like Vercel, for example, where you serve a bunch of HTTP assets. Definitely do not need a Kubernetes cluster for that, right?
Right.
So it does make sense to put something like on Cloudflare or Vercel or Netlify. So that's example of serverless, I think, really shines for me.
Now, is that like, if you have a website that's very busy, just stand up some VMs, as you said, you don't need Kubernetes for that, but maybe it's just a few instances of, Nginx, serving up static assets or something like that. Like, do you need to go full on serverless where the thing has to wake up whenever it receives a request, or is it? Yeah, I don't know. I've been kind of an anti-serverless guy from the beginning, but I always thought, in the back of my head, is this one of those, getting a little older, is this one of those get off my lawn situations? And so I kind of temper that, but I've always been skeptical of, really the utility of serverless since the onset. I just feel like they're probably less applicable than we think it is. It's just overhyped. There may be something like if you have to do a process that runs for 5 minutes once a month, standing up dedicated hardware and a process running the whole month where it just says, oh, I'm going to do this for 5 minutes. Yeah, I can see that being serverless, but something that's processing transactions all day long. It just seems silly to wake it up, for every transaction. And
Right. And it's going to end up being way more costly than what you'd have to pay if you stood up your own infrastructure.
Yeah, exactly. Well, just like serverless was, the holy grail. I mean, it's the same concept in the microservices world. We talked about it earlier. Everybody started off doing HTTP calls, and then eventually everybody's like, okay, we need to move to where everything is event driven. What's your take on that extreme view? Well, I don't want to call it extreme. That's kind of leading the witness, I guess. But going to that extreme where we get rid of all HTTP calls, everything is event driven. What do you think about that?
Well, I'd have to say ship it, but with nuance.
Mm-hmm. Okay.
So, going through a centralized message broker gives you a lot more reliability. It allows you to free up your resources when you don't need them. And it really allows for very simple programming models and decoupling systems, which I think is a great architectural achievement for many teams. So yeah, unless you absolutely need to wait on a response, then I would say do everything in an event-driven way for sure. I just think it's, that the technology today and the amount of knowledge that has been gathered for how to interact with things like Kafka or MSQ and SQS and the different cloud provider options that are really top notch these days. In the early days, they kind of fell apart because cloud was just starting and people were like, oh, I'm doing this event driven thing, but the cloud's now returning an error to me and SQS is down or whatnot. It's not like that anymore. And I think the Apache ecosystem specifically has a bunch of really, really great projects like Pulsar and Kafka itself. And you've got other things like RabbitMQ for queues. So yeah, you need to understand the different semantics between PubSub and queuing. But once you do, I think it gives you a really, really great tool in your toolbox to be able to do that and just use in your architectures.
Okay. We didn't land on this ship it or skip it topic as we prepared for the episode, but it just came to mind. So bear with me. It might not be a good one. One of the things I've seen a lot of, you see a lot of articles about this, and it seems to be a popular option, but, you and I both grew up in event-driven world, and we were always told, using a database as a queue is an anti-pattern, right? That's a code smell. That's right. But you hear a lot about this outbox pattern, right? So it's effectively write the messages that need to go into some sort of message broker into a database first, and then it gets outboxed to the messaging system. It just I just implemented. I literally just wrote something with the outbox pattern yesterday because I was like, it seems like it might actually work, but I just felt dirty doing that because I've always been told if you're doing queues in a database, that's an anti-pattern. You want those rolling logs, append only, that journaling type of thing. What's your take on the outbox pattern? What do you think?
Interesting you bring that up. Ship it for sure.
Okay.
In Dapr, we actually have an abstraction for outbox. So Dapr has a native feature called outbox where you can bring in any database in any message broker and you can create an outbox combination with them. And to your point, I think you shouldn't feel bad about it because the outbox pattern basically says, look, you've got a business transaction, you've written it to a database, and now you want to alert someone downstream that the data is saved. And that doesn't mean you're using database as a queue. It just means that you needed to write the data anyway to the database, but you want someone to know and you want to do it in the same transaction. You want it to be done, in an atomic way.
Yeah.
And I think it's a great pattern for that. If you're talking about using databases as queues, CDC is much more like that, where you're basically capturing every data that happens in the database, and then you're handing it over for processing, less for notifications. But with Outbox, I think it's a great pattern.
Yeah, I mean, as I said, I felt dirty, but I'll tell you what, when I started getting it built and I started seeing it working, and like, as you said, I love the idea of like, okay, do a business transaction. I save the information to the database, but also I save the outgoing event to the database in the same transaction. So I know I atomically have all of that covered, and it's somebody else's problem to make sure it gets forwarded to the messaging system. Ooh, man, it was nice. It really, it was like, I got over it pretty quick. I was like, okay, I can dig this. I like this. Okay. All right. I'm gonna ship it. I've gotten over my, get off my lawn thinking. So I'm gonna ship it on that as well. Okay. I'm glad you said that as well, because I was feeling like I'm like selling people out by like going to the dark side or something.
Oh no, definitely not.
Okay, so we've talked a lot about distributed systems. We went into agentic and all of this stuff. Where does this go? What's your vision? What are you thinking we're headed? What's the next step? What's in the future for us when we're building these type of systems?
Yeah, I think AI is definitely going to take a much bigger part, and I don't necessarily like this myself, but it's just what I'm seeing. Mm-hmm. I think where we're headed to, and only time will be the judge if what I'm saying right now is actually going to come to pass or not. But I think we're going to start seeing systems that write their own code in real time based on the objectives that they need to do. So you basically task them with something that they've never encountered before. And if they don't find the tool to execute the job, they're just going to write it themselves and generate the code, because like they can do that. If we go to ChatGPT and we ask them to write code for something, then they give us the code, we copy and paste it, we put it into the IDE, we build a Docker container around it, and we ship it as a tool to be used in an agentic system or by itself. But what if they could basically write their own code and infer their own logic? And I think we're going to be seeing more of that. So more automation, more code being handled to AI systems. And I think the CNCF ecosystem is going to transition from this DevOps-centric world that it came out of and grew out of with, Google coming up with Kubernetes and giving it the CNCF. And they're going to have to evolve into infrastructure for AI and for developers to be able to integrate AI and make it reliable. And that also talks back to the saga pattern that you mentioned earlier, because AI agents are coming up with different types of saga patterns that are unique to them. And we really don't know how to secure and monitor and observe all those. So I definitely think that the entire infrastructure piece in cloud native is going to be more AI native than it is cloud native. And this is where I see it's going.
And it's interesting that you bring up like they write their own code, like the agents write their own code to do the. I think we're somewhat there already, because you're seeing that pattern in some of the like the assistants that you mentioned. Like I noticed the other day, I was using Claude. Not Claude Code, but Claude, to help me write a document. And instead of just like generating the docx, so for like a Word doc, it's like, hold on, I'm going to write some JavaScript that generates that docx file for you. And then I'm going to execute that JavaScript. And I'm like, whoa, okay, this is new. And then even like Claude Code is my particular favorite for coding, but it will, as it gets into something that's pretty complex, it will write a little JavaScript file to automate what it's trying to do. And like, oh, I need to find this, like, especially for like migrations of code, like changing how it does things in multiple files. It's like, wait a minute, that's repeatable. Let me write some JavaScript or Python or whatever. And it kind of just does that on the fly. So that's kind of cool. It's kind of like when they give the astronauts a 3D printer, it's like they can make their own tools when they're up in space. So, okay. Very cool. All right. I like it. I think it's an interesting future for us for sure, but it'll be fun to see how do we keep these things under control.
Oh yeah.
All right. Our next segment of the show, and this is by far the most popular, and I have zero stats to back that up. I have no data that says that. It's popular to me. I like this segment of the show. So it is the most popular, but this is what we call our lightning round.
It's time for the lightning round. Rapid fire, don't slow down. Answer quick and make it count. In this game, there's no way out. It's time for the lightning round.
And the lightning round, there are correct answers. We have a very rigorous grading process that we go through. It takes a few weeks to tally everything together. We have, there's machine learning, there's all sorts of advanced algorithms to get this stuff right, to get the right, your score. So we'll have to send that, later what your score was. But I'm going to ask you some questions. These are very important. This is the meat of the conversation. This is what everybody tunes in for. Most people probably just skip all the stuff we already did and just go right to this, the lightning round, I'm sure. Are you ready? Do you feel you're prepared for this lightning round?
I am mentally prepared. Yes.
Okay. Well, good. Because that is important, to be mentally prepared. Are you a cake or a pie kind of guy?
Cake, for sure.
Cake. Okay.
Yeah.
Why is it that we are unable to tickle ourselves? What causes that phenomenon?
Well, we can I would argue you can if you have like an extension, like if you take a feather and you tickle yourself out.
Okay.
You could. So by extending your body with a third-party device, you could achieve that. Just saying.
Okay. Have you ever worn socks with sandals?
It's a good. I'm trying to think back now. No, I have not.
That's a good answer. That's a solid answer. I like that one. Are you able to say something in an Asian language?
Yes. Should I? Yeah.
Yes, go ahead. Sure.
Aomi Tofo. It's may the Buddha bless you in Chinese.
Oh, fantastic. Okay. I was thinking, like, for me, it would have to be like something my kids watched on TV. I don't know. I grew up in a karate, we did karate for 20 years. So I know some like dojo Japanese, which I'm probably butchering it. Yeah. How many times did you sneeze in the last 7 days, do you think? It doesn't have to be an exact number,
Zero.
Order of magnitude.
Zero. I can
Zero.
0 times. Yeah.
0 times. No, you're not a sneezer.
No.
Now you're in Seattle.
I am.
Is the air there very nice? Not a lot of pollen and stuff like that?
Yeah, and I also don't leave the house that much, so
Okay.
Probably that has something to do with it.
That makes sense. Makes a lot of sense. When it comes to dogs, a big dog or a small dog kind of guy?
Big dog. Yeah.
Okay.
More to hug.
Yeah. A lot of, except when they're really big and they decide, I want to be a lap dog. That gets a little problematic. But
I had a Great Dane when I was a kid. So.
Did you really? Yeah. Oh, they're great dogs. They're so sweet. If you had the choice, would you climb a mountain or jump from a plane?
Climb a mountain. I have a fear of heights.
Okay.
So I wouldn't do both if I had to, but if I had to choose, yeah, I'd be climbing a mountain for sure.
And if you were in a position where you were really hungry, like kind of a, really, really hungry, would you eat a bug?
Yes.
Yeah.
Okay. Most likely.
Are you the kind of person who Instagrams your food? Like the camera has to eat first or the phone has to eat first kind of thing. Is that you?
Definitely not. No.
Okay.
No, not in a million years.
Okay, good. Would you ever go to a movie alone?
No.
I have. Wasn't proud of it, but I have. When I traveled for work, there's nothing else to do. You go see a movie. It's fine. I have been in a movie theater by myself. No other people in the movie, just me and the screen. It was really cool. And it was kind of cool. I was like standing up taking selfies in the middle of the movie and nobody yelling at me about it. Do you own a bicycle?
I've never ridden a bicycle in my life. Would you believe that?
Wow. So that's a no. But now,
no.
Because that's not really the answer to the question. Because I own a guitar, but I can't play my guitar. I've always wanted to learn.
Interesting.
So I've owned a guitar my entire adult life, but have I sat down and practiced and done, no. So anyway, what do you set your thermostat temperature at?
68.
68. Okay. Yeah. That's down on the lower end of the spectrum for what we got. If I'm remembering some of the other people's answers to this. Okay. And we'll do our last question, the final question of the lightning round. This is the last of the last lightning round questions. What is your favorite carnival food?
My favorite carnival food is, can this be a multi-choice? I'm not sure I know what carnival food is.
Well, I think like when I go to a carnival, I think of like anything deep fried. We call them elephant ears, but it's like that fried dough with powdered sugar on top. Sometimes they'll put like fruit on it. That's one that I think of. Corn dog, cotton candy, anything like that.
I'm going to have to go for corn dog then.
Yeah. Corn dogs, you can't beat a good corn dog. You know what I mean? Yeah. I mean, I guess you could beat it. Like a steak probably would be better than a corn dog. But if you're at a carnival, though, not a lot of other options. I feel like the corn dog is a good one. Okay. We're done with the lightning round. So the pressure is off. You can kind of relax now. Now we're back to just normal, just conversation. Yeah. You made it. You made it through. I think you did okay. I think you did okay.
I think I did too.
Yeah. Any closing here, we're going to wrap it up here. Anything like anything you'd like to share as far as like kind of a practical takeaway from kind of the work you've been doing, or some of the stuff we've been discussing?
Yeah. So, I'm doing a lot in the AI reliability space. So giving agents the ability to basically pick up where they left off if they're executing thousands of operations. So I would urge your listeners to go and check out Dapr, because we have something called Dapr agents, which we're doing with NVIDIA. And it's basically AI agents that are reliable and have identity built in. So this is something that I'm passionately excited about today, and I would like everyone to check out.
Is the answer kind of along the lines of like event-driven event sourcing, like for that state of the LLM, or is that too much?
So we actually have a workflow engine that is Saga-based that sits at the underlying layer. And we've got the agents basically building real-time workflows using it and saving the state through that Saga orchestration engine.
Gotcha. Okay. What about anything coming up? You got a big blog post coming up? Any new releases of the open source stuff coming? Are you speaking anywhere? You got a book? You're doing a video? Anything like that coming up that you'd like to share with us?
Yeah. So I've got 2 talks at KubeCon North America. Nice. Where I'm giving about durable execution and AI agents, and also sharing the future roadmap of the Dapr project. And then I do have a book that I wrote in 2019 with O'Reilly. It's called Learning Dapr. So that's a pretty good book if you want to learn about the project and how it started and the history around it at Microsoft. Most likely I'm going to renew it for a second edition at some point. So.
Nice. How long do you typically, what's the timeline on second editions for technical books? What does that look like?
Yeah, it should be like a 6-month process.
I mean, but how many years after an initial edition is that a 5-year that the initial edition usually lasts, or does it just depend on the topic?
It's dependent on the topic, really.
Okay. Yeah. I'm just curious how that works, because I have a lot of first and second editions of the books on my bookshelf. I keep the first one for some reason. I don't know why I do that, but all right. Well, this has been fantastic. Thank you again for joining us. I really enjoyed the conversation. This was great.
I did too. Thank you.
Yeah, absolutely. Well, also, if you'd like to learn more about Diagrid itself, that is www.diagrid.io, and that's DIAGRID.io. Anything in particular on the website that you'd say you've got to go here? What section of the website would you tell people to go to?
Go check out the Catalyst platform. That's our platform for workflow orchestration and AI agents.
Okay. Yep. That's what you were talking about earlier. Okay, great. Fantastic. If you'd like to get in touch with us here at the /, drop us a line at the /@calibrity.com. See you next time. The / podcast is created by Calibrity. The / team is director and producer Ryan Wilson, editing by Steve Baradelli, marketing support by Taylor Blessing, and I'm your host, James Carman. Thanks for listening.